start our new chapter, the S block elements, Unit 10. First, we start the objectives. After studying this unit, you will be able to describe the general characteristics of alkalis, metal, and their compounds. Explain the general characteristics of the alkalis, earth metal, and their compound. Describe the manufacture properties and use of industrial important sodium and calcium compounds including Portland cement. Appreciate the biological significance of sodium, potassium, magnesium and calcium. The first element of alkali. The first element of alkali and alkaline earth metal differ in many respects from the other member of the group. The S block elements of the periodic table are those in which last electron entered the outermost s orbital. As the s orbitals can be accommodated only 2 electrons. Two groups, first and second, belongs to the S block of the periodic table. Group first of the periodic table consists of the elements lithium, sodium, potassium, rubidium, cesium and francium. They are collectively known as the alkali metals. These are so called because they form hydroxide on reaction with water, which are strongly alkaline in nature. The elements of group second including beryllium, magnesium, calcium, strontium, barium and radium. These elements, with the exception of beryllium, are common known as alkaline earth metal. These are so called because their oxide and hydroxides are alkaline in nature, and these metal oxides are found in the earth crust. Among the alkali metals, sodium and potassium are abundant, and lithium, rubidium and cesium have much lower abundance. Francium is highly radioactive. Its longest life isotopes 223 francium has a half-life of only 21 minutes. Of the alkaline earth metals, calcium and magnesium rank 5th and 6th in the abundance respectively in the earth crust. Strontium and barium have much lower abundance. Beryllium is a rare and radium is the rarest of all. Comparison, only 10 to the power negative 10% of igneous rock. Table 10.2, page number 299. The general electronic configuration of S block element is noble gas NS1 for alkali metals and noble gas NS2 for alkaline earth metals. The thin rock over a layer of the earth's crust type rocks, igneous rocks, a type of rocks formed from magma, molten rock that have cooled and hardened. Lithium and beryllium, the first element of a group and the second group respectively, exhibits some properties which are different from those of the other members of the respective group. In these anomalous properties, they resemble the second element of the following group. Thus, lithium shows similarity to magnesium and beryllium. To aluminium. In many of their properties, this type of diagonal similarity is commonly referred to a diagonal relationship in a periodic table. The diagonal relationship due to the similarity, ionic size and or charge radius ratio of the elements. Monovalent sodium and potassium ion and divalent manganese calcium ions are found in large proportion in biological field. These ions performed important biological functions such as maintain ion balance, nerve impulse condition. Then group first element, alkali metals. Alkali metals shows regular trend in their physical and chemical property with the increased atomic number. The atomic, physical and chemical properties of alkali metal are discussed below. First, we discuss electronic configuration. All the alkali metals have one valence electron, Ns1, outside the noble gas core. The loosely held s electron in the outermost valence shell of these elements have them the most electropositive metals. They radially lose electron to give monovalent and positive ions. Hence, they are never found in a free state in nature. The electronic configuration are given. Show the electronic configuration of lithium. Symbol is Li. Electronic configuration 1s2 2s2, sodium Na 1s2 2s2 2p6 3s1, potassium K 1s2 2s2 2p6 3s2 3p6 4s1, rubidium Rb 1s2 2s2 2p6 3s2 3p6 3d10 4s2 4p6 5s1, cesium Cs 1s2 2s2 2p6 3s2 3p6 3d10 4s2, 4p6 4d10 5s2 5p6 6s1 or xenon 6s1, francium Rn 7s1. Then atomic and ionic radii. The alkali metal atoms have the largest size in a particular period of the periodic table. With increase in atomic number, increases in atomic number, atoms become larger. The monovalent ion M positive are smaller than the parent atom. The atomic and ionic radii of alkali metal increased on moving down the group. They increased in a size while going from lithium to cesium. Then ionization enthalpy. The ionization enthalpy of the alkali metals are considerable low and decreases down the group. The main point to be noted, ionization enthalpy decreases down group from lithium to cesium. This is because the effect of increasing size overweight the increasing nuclear charge, and the outermost electron is very well screened from the nuclear charge. Then hydrazation enthalpy. The hydrazation enthalpy of alkali metal ions decreases with increased ion size. When ion size is increases, then hydrazation enthalpy is decreases. Lithium has maximum degree of hydration, and from this reason lithium salt are mostly hydrated. Then physical properties. All the alkali metals are silvery white, soft and light metals. Because of large size, these elements have low density with increases down the group from lithium to cesium. However, potassium is lighter than sodium. The melting and boiling point of alkali metals are low, indicate weak melting point due to the presence of only single valence electron in them. The alkali metals and their salts impart characteristic color to an oxidizing flame. This is because the heat from the flame excites the outermost orbit electron to a higher energy level. When the excited electron come back to the ground state, their emission of radiation is visible region of the spectrum as given below. Metal, color and wavelength. In wavelength by nanometer. Lithium crimson red color and wavelength is 670.8. Sodium yellow color, wavelength is 589.2. Potassium violet color, wavelength 766.5. Rubidium red violet color, wavelength 780.0. Cesium blue color and wavelength is 455.5. Alkali metal can be detected by the respective flame test and can be determined by flame photometry or atomic observation spectroscope. These elements, when irradiated with light, the light energy absorbed may be sufficient to make any atoms to lose electron. Then table 10.1, atomic and physical property of metals. Property: atomic number lithium 3, atomic number of sodium 11, potassium 19, rubidium 37, cesium 55, francium 87. Atomic mass of lithium 6.94, sodium 22.99, potassium 39.10, rubidium 85.47, cesium 132.91, francium 223. Electronic configuration: helium 2s1, sodium neon 3s2, potassium, we already discussed the electronic configuration. Ionization enthalpy of lithium 520, sodium 496, potassium 416, rubidium 403, cesium 376, francium nearly 375. Hydrogen enthalpy: negative 506, negative 406, sodium negative 406, potassium negative 330, rubidium negative 310, cesium negative 276. Metallic radius: metallic radius of lithium 552, metallic radius of sodium 186, metallic radius of potassium 227, metallic radius of rubidium 248, metallic radius of cesium 265, ionic radius of lithium 76, ionic radius of sodium 102, ionic radius of potassium 138, rubidium 152, cesium 167. Then melting point and boiling melting point and boiling point given in the table. Density also given. Standard potassium are given, occurred in lithosphere. What is lithosphere? Lithosphere means the earth over layer, its crust and part of upper layer. Then chemical properties: the alkali metal are high reactive due to their large size and low ionization enthalpy. The reactivity of these metals increase down the group. Reactivity toward air: The alkali metals tarnish in dry air due to the formation of their oxide, which turns react with moisture to form hydroxides. They burn vigorously in oxygen, forming oxides. Lithium form monoxide, sodium form peroxides. The other metals form superoxide. The superoxide O2 negative ion is stable only in the presence of large cation such as potassium, rubidium, cesium. The reaction is given of the oxide and peroxide, superoxide. Then in all these oxides, the oxidation state of the alkali metals is positive one. Lithium shows exceptional behavior in reacting directly with nitrogen of air to form the nitride Li3n as well because of their high reactivity toward air and water. Alkali metals are normally kept in the kerosene oils. Then reactivity toward water. The alkali metals react with water to form hydrogen and dihydrogen. Then reaction is 2m plus 2H2O to form 2m positive plus 2OH negative plus H2. M is an alkali metal. It may be noted that although lithium has most negative value, its reaction with water is less vigorously than the sodium, which has less negative value among the alkali metals. This behavior of lithium is attributed to the small size and very high hydration energy. Other metals of the group react expansively with water. They also react with proton donors such as alcohol, gaseous ammonia and alkynes. Then reactivity toward dihydrogen. The alkali metals react with dihydrogen at about 673 Kelvin, lithium at 1073 Kelvin to form hydride. At alkali metals, hydride are ionic solid with high melting point. 2m plus H2 to form 2m positive, H negative. Reactivity towards halogens. The alkali metals readily react vigorously with halogen to form ionic halides. M positive, X negative. However, lithium halides are somewhat covalent. It is because of the high polarization capability of lithium ion. Dispersion of electron cloud of the anion by the cation is called polarization. The lithium ion is very small in size, has high tendency to distort electron cloud around the negative halides ion. Since ion with large size can be easily distort among halides, lithium iodide is the most covalent in nature. Reducing nature. The alkali metals are a strong reducing agent, lithium being the most and sodium the least powerful. The standard electrode potential, which measures the reducing power, represent overall change. M solid to form M gas. Sublimation enthalpy. M gas to form M positive gas plus electron. Ionization enthalpy. M positive gas plus H2 to form M positive in aqueous solution. Hydrogenation enthalpy. With the small size of its ion, lithium has highest hydration enthalpy, which account of high negative standard electrode potential value is high reducing power. Then solution in liquid ammonia. The alkali metals dissolve in a liquid ammonia which give deep blue solution which are conducting in nature. The reactions will be given M positive in bracket X plus Y NH3 to form concentration bracket M in bracket NH3 bracket close X plus E concentration bracket E NH3 bracket close Y negative. The blue color of the solution is due to the ammonate electron which absorb energy in the visible region of light, thus impart blue color of the solution. The solution are paramagnetic or standing slowly liberated hydrogen resulting in the formation of amide. M positive amide plus electron plus NH3 liquid to form MnH2 amide plus half H2 gas, which Am denoted solution of ammonia. In concentration solution, the blue color change to bronze color and become diamagnetic. Uses: lithium metal is useful to make alloy. For example, with lead to make white metals, bearing motor engine with aluminium to make aircraft parts, and with magnesium to make armor plates. It used in thermonuclear reaction. Lithium is also used to make electrochemical cells. Sodium is used to make Na or Pb alloy needed to make PbEt4 and PbMe. These organoletes compounds were earlier used to anti-knock additive to petrol, but nowadays vehicle used lead-free petrol. Liquid sodium metal is used as a coolant in the fast breeder nuclear reactor. Potassium has a vital role in a biological system. Potassium chloride used as a fertilizer. Potassium hydroxide are used in manufacturing of soft soap. It also used as an excited absorbent of carbon dioxide. Cesium is used in devising photoelectric cell. Then general character of the compound of the alkaline metals. This topic discussed on next video.